Thought I'd show you here about this puller that I had. It's the same puller that I used to get the flywheel off the magneto on the other end, and I noticed that these holes were quite a bit oversized for the screws I was using. This was the screw I was using to pull those, but if you make those holes a little bigger, you can put a 10mm screw in there, and believe it or not, it's the same bolt location or real close to it for this flywheel. But I'm not going to draw this bolt up tight. I want it loose a little bit, so that I can push on this bolt, but when the flywheel comes off, it's got enough room to move back. It don't have to be very much, a 1/16 of an inch or so will do it, but I just want it so as I can push on this bolt, because I've got nothing on the end of the crankshaft to push against. And these are the bolts that held that rubber donut spider and everything on there. So as you can see, they seem to line up okay. So it seems like one tool can be used for both things here. Anyway, this is the flywheel. I'm heating up this flywheel with a propane torch here. Actually, I'm running nap gas in it, so it probably gets a little hotter than just normal propane, but I need to get it up to about 400 degrees to make the Loctite let go on there. I think it's on a taper with a little bit of Loctite, I think, is on there. Hopefully I got that thing hot enough now. I don't know. It's 140 degrees if I can't keep my hand on it. It's close. That's out here. It'd be 140. In there it might be 400. I don't know. Up to that temperature, because I know that'll take care of the Loctite. So I got something behind here I want to show you, and that's why I'm taking this off. Or trying to. Well, that was the ticket. It's still pretty hot yet, so I'm not gonna try to pick it up to show you. But this white stuff on the taper here, that's what's left of the Loctite, I guess. So I got it off. That puller will work for both ends. It'll take off the magneto end, which is this thing here, but you have to use the smaller 8mm bolt for that, right, like that. And these 10mm jobs will fit this thing, but it's the same hole location. So this one puller seemed to work for both, as long as I made the holes in the puller big enough. So don't try to make it. Now what I'm going to do is try to measure the diameter of these wrist pin bearings in the rod to make sure that the rod, this is a telescope gauge, by the way, you just rock it through the hole and it'll tell you the diameter across that hole. It's not quite as good as a bore gauge would be, but it's all I got, and it'll certainly measure plenty close enough for what I need to know here. You put it crossways on the hole and then snug up the end of it and then just push it through. And then you can take a micrometer and find out what that distance is across there, which I would assume this way is probably what it was originally. If it's getting oval shape, it's probably going to be beaten out in this direction. So I want to see what the difference is one way to the other. That's what I'm checking on here. I'll say 860. I'll say 867. Close enough. 0.867. And then I'm going to put it through this way. Oh, it's still tight. I can tell that. It's fine. It's going to be the same thing. So it's as round as it ever was. Yep, 867. 67 thousandths, and it's nice and round. So that baby's like new there. Now I'll rotate this around and do the same to the other side. So nothing wrong with that part of the crank. And of course you can check for play in the lower rod bearing. Just you can feel that if there's anything, just pushing in and out on it, and I feel 0 on that. That's really good. Yeah, this thing's in great shape. So I don't think I need to replace the crank, but I'm still going to take the bottom off because I got something I want to show you in there. I'm going to show you something here real important that I think is pretty important, and that is these little yellow dots of paint in this line right here, which basically goes to that bolt hole right. Those paint dots are something that I put on there, probably with some of the t-shirt paint. What they mark is a position on this seal and where the oil hole enters that bearing. Now I never hear anybody talk about that. There's little feet on this seal, and where this seal goes into the crankcase, that makes a big difference on blocking the hole, and the hole is in here. I'll use a pencil to point at it. Right here is an oilway. You get the same thing on both ends of this thing. That oilway is an oil passage that lets oil run down. It condenses in this, collects in this groove right here that you'll see machined in there, and it goes down that little hole right there, if you can see it. It goes at an angle this way, and it comes out right behind this seal. Now the little seal has little feet on it that distance the seal a certain distance from the bearing, and you'll see that when I get the crankshaft out. If you don't have this seal positioned right, and I never hear anybody talk about this, and I think it's real important, that little foot, if it's turned wrong, can plug up the hole where that oil comes into this side of the bearing. The oil goes in this side of the bearing right behind this seal, and then goes through the bearing back inside the crankcase. It's part of the oil circulation on this thing, because you really don't have an oil pump or anything, so you have to make sure there's nothing restricting it, because there's pressure going back and forth in there that's blowing oil around, kind of like a refrigeration compressor or something. Something I forgot to show you before is taking off these piston rings and putting them on. A tool like this helps. I guess I got that back when I was in high school, so it's pretty old. But you put this tool around your piston ring, and there's little pry fingers there that pry it open, which makes it easy to get the ring. Okay, I did find something here that I really don't like, which is on top of here. I don't know if you can see it or not, but you see this discoloration around here. There's been water laying in here, because this is actually the top of my engine is what we're looking at, because the engine's upside down on the airplane. So what I'm thinking a modification I might make, which might help some, is to drill a hole at the base of this down in there. This is where the gearbox is here for the skew gear. I might put a hole, a little small hole in there that'll come out right there with a electric drill, go in this way and drill a hole through there to let the water drain out of there. I think that would probably be. Anyways, I'm ready now to try and get this case off here. I think I've got all the bolts out. Let's see if usually just takes a little bit of tapping. It should come off there. There's what I want to show you are these paint marks I put on here, and the reason for those is to help me position this seal right here, the end seals on here where the crankshaft bearings are, because they're a little distance spacer feet. I don't know if this camera's going to pick it up. There's one right there. This little bit of rubber sticking out on this seal spaces the shaft seal just the right distance from that bearing. But those little feet can cover an oil way. And I'll take... Now I hope you can see this. You see, this is where this oil hole comes out. It's an oil way that comes from that little oil gallery I was showing you at the base of the transfer ports. And it allows the fuel and air mixture to blow oil down through this hole. Now it can't come out of this big area here, you see. It can't come out of there because there's a bearing right over top of that. The ball bearing fits right over top of that. And if you look, I think you can just about make it out on here. It's black, it's hard to see this stuff. But right here is one of those little feet I was telling you about. It's a distancing thing. And around this seal, you can see other feet. Here's one right here, sticking out. That's supposed to distance this crankshaft seal the right distance from the bearing. But you can see here, I never hear people talk about this, and to me it seems pretty important. This right here is covering up the slot where that oil could get in there between the seal and the bearing. And you want that oil blowing through the bearing. I never hear people talk about that. So what I've done over here, you see that paint mark, and if you look on the back of this seal somewhere, right there's my paint mark. I fixed it so if you line the paint marks up like so, you can see there's more space here because there's no feet blocking that slot. There's one over here on this side of it and one over here, and that's what the paint mark tells me is where I should mount that thing, so that those feet are going to miss that little oil way there. The other thing I did, this is just my idea, I took a Dremel tool and I elongated this area here to allow a little more area for that oil to blow in between this seal, because that's how the oil's coming down, and it's going from the outside of the bearing in towards the center. The whole crankcase on a 2-cycle is really basically just part of your intake manifold, but oil's going to be traveling along the metal parts of this thing. So anyways, that's what that was all about, and I just kind of ground that a little bit to make it a little easier and maybe have a better chance, because I think when mechanics put these together, they just put the oil seal in. They don't worry about those little feet, but where those go in there, I think is kind of important. So that's the modification I wanted to tell you about there, is I think that's very important. Water pump shaft here. We're on the water pump side, and this is the water pump seal here. Haven't had any trouble with the seal leaking, but if it does leak and it gets past another seal that's behind it that seals on this shaft where the skew gear, this is a gearbox in here, very narrow, it's about 1 inch wide, which is where this skew gear runs to turn the rotary valve shaft. Okay, there's a hole that goes right in here, and this is supposed to be kept open. This is a drain hole that allows coolant to come out if anything gets past the seal behind the impeller, and that means whether it's a lip seal or a mechanical seal, you got to have a drain in there between there. And it has to be open so that water or coolant can get out of there. And what people, I guess, were noticing is that the coolant would be getting into this gearbox, and the rotary valve oil would be kind of milky. You know, it would look like an emulsion of oil and water, because it was getting past the lip seal in there, because it's quite easy to go past the seal in one direction. Lip seal only holds stuff in one direction. It's not made for two directions. So now I've heard of people saying, well, pack this thing full of grease, this hole down in there, and pack that cavity full of grease. There was a set screw in there which I took out. It was down in there. I think it was Loctite in. I remember it was pretty tight. I had to heat it a little bit, I think, to get that set screw out of there. But they plugged it up with that, and that's because, I'll show you here, this slot right here that they milled in here was the provision that they had to allow any coolant. Actually, it'll let any coolant or oil out of that space between those two seals in there. Like I say, the one that's on this side seals in the oil for the gearbox, which is here. There's a seal in there that seals that, and then over on this side is the one that seals in the water. So this is how I made this Grayhead 582 not give any problems with the coolant. I don't pressurize the cooling system, so it's just not trying to wear a groove in that shaft. And also, I took this set screw out of here so that it has a drain. Now the drain's going to allow the water to come out this slot here, and it comes out between the cases here, where the cases are bolted together. And people probably would get excited if they see something coming out of there, but it's supposed to. That's how it gets rid of anything that leaked past the shaft seal. And if you've got pressure on the cooling system, that little lip seal on the shaft, if it leaks anything, would come up, it would come out of this hole right here and into this slot, and then of course right out between the two case halves. Get it focused right. Okay, right there. That's where that, let's see, right here is where that slot opens into this little, it's a cast-in cleared place that slot is open into, and that's where you're going to see the coolant coming out. It probably would just run down the block. There's no provision for putting any hose or anything like that on there, but it isn't going to be very much come out of there, or better not be. If it is, then you got a problem and you ought to solve it. But that's how they got rid of the leakage. That any leakage that came out of either one of those two seals is going to come out there. So it shouldn't be plugged up. That was really a bad move for them to do that. Or oil, either one, before it can come out this hole. But the main thing is it's not under pressure. There's no pressure that's forcing it into this gearbox. And that's what would happen if the seal got to leaking, the lip seal on the water pump, which, like I say, they're not designed for pressure. They're not designed to be used like that. So that's a real design drawback on this thing. I don't know. I think they use these on jet skis, and maybe they don't have any water pressure in there, and maybe they use lake water or something to cool it. I have no idea how that works. But one thing's for sure, you can't have those little tiny radiators and then put a pressure cap on there without having water eventually going to end up in this gearbox. You can see that. That's especially if you've got a set screw down inside this little hole right here, and that goes down right down to the shaft in there. And there's like I say, there's a seal right about in this area down in there, and another one over here. So okay, that's it for the modifications. That's what I did to the thing, and I'm not saying that this is the thing to do to every engine, and I don't know about other engines. I just know about this Grayhead, and like I say, I've run this thing for 20 years myself, and the engine's a lot older than that. It was, like I say, it's probably a 94 engine, but it's just fine. We haven't had any trouble with it in all that time with the stuff that I've been doing to it. And like I say, I've put no parts in it, no piston rings, nothing but gaskets is all I put in there. At one time we did change, this is when the other guy had it, this was more than 20 years ago, but we changed we changed the shaft seal on the water pump here. We changed that because he thought he was getting water in his coolant. His coolant was milky, and so, but that can be done on the airplane. You can take this shaft out of there and everything. And we did that. We pulled this shaft out, and we changed the water pump seals and the seal for the oil they keep in the gearbox. Both those seals we changed, and I think I got some special tools or something that he bought from Rotax to be able to do that. Just mandrels to help you push in the seals, but it can be done with the thing still on the airplane if you drain the gearbox. But I haven't ever had any trouble like that again, because I don't run pressure in the cooling system, and I think that's a real important thing. And I use a much bigger radiator than what those little ones that Rotax had on there. That's the biggest difference.